This is the Integ Visual Machine Overall Equipment Effectiveness System. It is a software-based system that utilizes the Integ Junior Automation Controller to gather key signals from production equipment, such as is the machine available in a production mode, making pieces or, or scrap pieces or gone into delays. The Visual Machine OE features include that it is a real-time system for automatic data collection, is scalable from one to many work centers, connects to any machine or work center type that's making discrete type of parts. It is a web-based setup and access anywhere, anytime from the web page. So you can do that anywhere on your network or remotely if you have the right IT type of connection. And you can view the screens on a PC, a tablet, smartphone, anything with a web browser, large flat panels. And it utilizes Integ's I/O hardware, the Junior, to make the system easy to install and allow you to grow. You do not have to modify any of your existing control systems. You just need to find some key signals to connect to the Junior. This is a picture of the Junior. This is our automation controller that you can connect one or multiple machines to. It does have 8 digital inputs, 8 relay outputs, 2 serial ports that can be used for miscellaneous type equipment, such as a barcode scanner, and does run data buffer software, and has its own web page for I/O monitoring and configuration. So you place your Junior automation controllers near the equipment and hook up one machine or maybe 2 or 3 to the Junior. They're on the Ethernet network. The information goes back to the central PC running the Visual Machine software. All the information is buffered in the Junior, sent to the central PC, stored in the database, and then all the web pages are served up from the Junior. This is the Visual Machine OE software. This is the overview page. It shows all the work centers. All of the colors do represent the status of the machine, whether it's running normal, such as white, or going to green where it's good. Yellow could mean it's in a warning, red a delay or running bad, and blue is a machine that's not available. So we have various web pages that I look at individual work centers where you can have the operator sign in or start a job, enter delays, enter scraps. We do show you the OE statistics by current hour or by shift or by job, the pieces made, any scrap pieces made. As I scroll down, I can see the cycle time. This is a stamp of when each piece was made, how long it was since the last cycle. And then up here we are keeping data showing you the target cycle time, 7.5 seconds. The last cycle time was was just changed to 2.6 seconds, and the average is 8.1 seconds. The colors in the graph do represent how well it's doing to its target. If it's in the green area, that means it's doing a 7.5 second cycle time or faster. There's a white area where it's in the normal, so it's not quite 7.5, but a little bit faster. And a little bit slower. And then yellow is even a little slower, so it's warning. If you get into the red, your cycle time is just too slow. You could change this and look at this by rate. And then by rate, we could see how our target is 8 parts per minute and our average is 8.1 parts. And so as long as the average, this dark black line, is running up in the green area, we're doing great. If it drops into the red, we're not doing so good. And we can switch that back to by cycle time. And if we scroll down some further, this will show us how we're doing in our current shift. We have just gone into the overnight shift. There's a total of 780 minutes in this shift, and the scheduled production time is 750. There's 30 minutes of scheduled downtime. This shows you the amount of time it's actually in production so far. In this shift, it is a real-time adjusting bar, how much has been available producing. The target output is the number of pieces that should be made, and this has been running for 25 minutes. and it's supposed to be making a piece every 7.5 seconds. So that's like 8 pieces a minute. So you should, in about 30 minutes, make 204 pieces. So it's actually 25.7 minutes times 8 is about 205 pieces. And then the actual output is 219. So we are doing better than target. And that's reflected up here in my OEE. I've been 100% available for this current hour. I'm running faster than my target because my average cycle time is 8 seconds. It's supposed to be 7.5. So I am actually meeting my target. And my quality, I've only made 1 scrap piece, so my OEE is 105%. So this is a very helpful screen for the operators to look at, to see their production, as well as do things like the operator can sign in, can start a job, select a work order, can enter delays, and select anyone from a number of reasons. And then you can enter scrap, and when you enter the scrap, it can increment the scrap count as well as decrement the good count. So we can do that for every machine, every work center that is out there. We can look at their production and how they're doing and see what's going on there. And then we do have data views where you can look at various views of the data. So we have timeline views, table views, and panel views. So if I look at a panel view for my all signal machine, what it'll show me is it's something like you would use on a flat panel TV on the wall, or maybe on your web page you want to keep it up on your screen. The color does follow the color of the work center. So if it's in a green mode, the background will be in a green. It does show you the last cycle time, average cycle time. These are all selectable under configuration, which data you want to show. So you can have many of these configured. And then we can also have what we call a table view. And a table view is ideal for seeing multiple machines and what's going on. So I can see, like an Excel spreadsheet, I could see all the information. And of course, the colors do reflect the actual status of the machine, whether it's good, normal, bad. And again, these columns that I show are all configurable. And then one of our news features is the timeline, where I could select a current shift, or maybe I'll go farther for so that we can see the last 12 hours of this work center. And it will show us 3 rows. The top row is basically saying within a 20-second time period did I make my cycles. The middle row is the state. Was it in a delay? Was it just running bad or slow? Or was it running good as in a green mode? And I can have these timelines. They're meant to be a quick look at how overall your machines are doing. So if I wanted to have multiple machines, I could select multiple machines and show them all and see how their status is. And by the way, the bottom row is the shift, so I can see where my schedule breaks are going to be. And these are just fictitious made-up shifts. This is a simulator running in our office. We do have reports so that I can see a production report, for example, by a work center, and I could see how the all signal machine was doing. And this production report will show me for the morning shift how many pieces were made, good, bad, its quality. The target count is based on the target rate. If I'm trying to make a piece every 7.5 seconds, I should be making, in 60 minutes, 480 pieces. And I can see that I did not hit those targets. So that's my efficiency. And then for the afternoon shift, and then the overnight shift, you can see where you are. And then there's some plots of that data of the shifts. And of course, I can go back and look at yesterday's data. And of course, I could make a PDF of this information. I can also look at production by work group. Say I had multiple machines all grouped into something called the simulator. And that would bring up these 4 different work centers are all categorized in the same group, and then add up their production together. This is helpful if you have the same work center, multiple work centers making the same part. And then we do have delays. So I could see a delay report I haven't really entered any delays, so there's no delays showing up. We have delays that can be automatically detected or manually entered. I'll show you the automatic here. And then we do have delay trends. So if I wanted to see what the key delays were for this work center, today, yesterday, this week, and this month, I could see all the delays. And if I wanted to, I could also do the delay trends for the whole plant, where these are aggregates of all the work centers for today, yesterday, this month, what type of delays there are. And then we do have an efficiency report where I could look at the efficiency of a specific work center or of a group. And the color codes are based upon breakpoints where white is normal, yellow is a warning, red is bad. So we can see what the efficiency is of the work center, or I can look at by group, or I can look at the efficiency for the whole plant. If you log in, you can get to the configuration. In the configuration, I can see things like selecting the colors that I want to use when I'm in a good mode or bad mode, normal, certain preferences that you can do. I can set up my shifts for my real shift. When does the shift start? When do I have scheduled downtime so I can back this out of my availability? I can have users and set up various users to log in. Here's where I add my work centers. I just simply add a work center, and then I can put it in various groups. I could have a delay start automatically when there's no production, and then I can stop the delay after so many pieces are made. So I can have my delays automatically started and automatically ended. And then I just simply pick what inputs on the junior I've wired up for the various signals we're looking for, like the available, production mode, piece made, or scrap piece made. We can control outputs like and-on lights. So when the status of the machine goes in like good, we can turn on a certain output on the junior if we wanted to, and that output could be wired to an and-on light. We can do that with delays too, just simply select which junior you want it to go to, and then which output it's wired to. You can define delay reasons, and you can then configure what delay reasons this work center shows when the operator clicks start a delay. Same thing with scrap codes, so you don't have to use them all on every work center. You could selectively add them to work centers. And then we do have various defaults on what the production rates are if there's no work order entered. If you do build a work order is going to consist of parts, and then the parts are going to consist of a route to go through that work center and then what your target rate is. So if you do allow the user to select a work order, the work order will start a part, and then that can define what the target rate is. So if your machine uses various parts at different target rates, it's better that you select the proper part so you get the proper target rate so you can calculate your efficiencies correctly so that you know how much the machine should be making. Then if you're into the tables and panel views to make, it's very easy to create these panel views and edit them. You can just simply click on the button and select which ones you want. This is the Excel spreadsheet based one. And if you're into the panels, you can simply select the panels, pick any one of the data points you want, and you can even change the format so that you can have it a 1x1 up to a 3x3 grid. And then going down on your delay reasons, you can have various reasons, and then you can summarize these reasons into various categories. So like if you have a reason, you can select which category to put it in. So that just allows it to make it easier for the operator to see the delays. Same thing with scraps, you can have categories, and then you can have various scrap reasons. and each scrap reason can go into a target. And then, so that's pretty much a quick overview of what the system looks like. And as I mentioned, you could have the operator sign in, and once the operator signs in, here I will go to what I call my manual test station so that I can control a few things. Nothing is logged in right now, and the target cycle time is 10 seconds per part. I do have a junior configured that the outputs are wired to the input so that I can simulate the system running here. So on this junior here, if I turn on output 1, which turns on input 1, and it's configured to be the available signal, you see that my work center is now available. And then I can put it into a production mode. So now the system is expecting to see parts being made, and it's going to start calculating a pace based upon the target. And then if I start making pieces, you will see that I'm making pieces and that the counts are incrementing and that I'm calculating my performance. And you can see the availability is increasing because ever since I've turned on the available signal. If you don't have these signals defined in the work center, you can just use a piece made. Then the availability simply becomes the shift schedule. If you use the availability signal, then it's defined based upon whether the signal is or is not available. And you can see I'm making more pieces. And you can see that I'm being time-stamped, and you can see my color bars based upon my target rate of 10 seconds. And then if I make a scrap piece, you will see my scrap increments by 1 and my good goes down by 1. And then I can stop this, and you'll see my signal has gone back to be not available. Now if I were to sign in an operator, which I don't have to do that, but if I sign myself in, and then I start a job from this work order, and this will be a target rate of 6 seconds per piece, and you will see that my target cycle time has changed to 6. And now when I start making pieces, you'll see it's now going into the available mode, and then I can go into the production mode, and it's looking for pieces being made, and I'm making pieces again. And you'll see my graph looks a little different because this color is showing me that my target with about a 10% error is 6.7 seconds. That error is defined under configuration under performance that I said my acceptable performance is within 90% of target. So if I can go, within 6 to 6.7 seconds, I'm in the good mode. 85% is normal, 80% is warning. If I go back to that work center, you see I've gone into the bad because my average cycle time is 14.5. But if I start making pieces again, and if I make them real fast here, I can pull my average cycle time down. And you can see my last cycle time I'm running in at 2 to 3 seconds. And my average cycle time is coming down. So I'm only in a warning zone right now. Now I'm into the good zone because I have brought my average cycle time. You can see the black line in here. It's coming down and it's in the green zone now. Now what I could do is I'm making pieces. I could enter a delay. So if I go into a delay because I have a mechanical problem, I have a breakdown, and say yes. And then if I turn off, I'm not in the production mode anymore. It's going to stop looking for pieces being made. But now I'm in a delay mode. If I were to look at any of my data views, such as my panel view for my all signal, you will see that that's the wrong work center. If I go to the panel view for the manual test, you'll see that it's in the red mode, which is matching my delay mode. So I have gone into a delay here, and if I were, I believe I have a data view that does show, I think it shows delays, but you can see who the operator is on manual test. It's me, my number. I'm in a delay for breakdown. It started at 17:39, and I've been in it for 1 minute and 7 seconds. You can see my last cycle times. And then if I were to go into that work center, and then I could end the delay, and I'm no longer in the delay. And if you look, of course, I've come out of the delay and I'm into the available mode. I go back into production, and then you can see I can start making pieces again, and everything is changing together, including the counts. If I move this, just my cycle times, you can see are changing, and we're back to making pieces again. So that is a demonstration of the Integ Visual Machine OEE system.